Hi, and welcome to this video tutorial where we're going to look at how we can join different tables together within SQL. But before we start writing the SQL itself, we're going to look at it theoretically and have a visual understanding of how different sets of data from different tables can join together. So we're going to look at that with the use of a few Venn diagrams. This video is part of a wider set of tutorials that you can find by subscribing. So if you click subscribe, then you can see the playlist that has all the videos that will teach you on how to write SQL. Once we've gone through the theory section on this video, then the subsequent videos we will look at some actual examples of writing the various different SQL join types. You can find all the videos in this series also by going to my website www.padsresearch.co.uk. That's physics, aviation and data science, and there you'll find a list of all of the video tutorials in this series. So let's get started and have a look at what the various different ways of joining data is within SQL. So when we join data, we're looking to take data from one table and then join it to data with another table. And you might on first thought think, well, there's only really one way of doing that. So we essentially take the IDs that exist in one table and we link those up with the IDs that connect with the other table. But that can have a few different results depending on how we actually connect those two tables together. So the first type of join that we do is an inner join. And if I put a Venn diagram on the screen, in a Venn diagram, we're going to have a circle, and that circle is going to represent the data from one of our tables. And then we can have another circle, and that's not what I want. So we'll duplicate that. So this other circle here, that's going to represent the data from the other table. So let's label this. Let's call this an inner join. So we'll give that a label, inner join. There we go. Right, so let's label the tables as well. So this is going to be table A. And then we want the other table to be table B. Right, so you can imagine that this is all the data from table A, and this is all the data from table B. And when we do an inner join, we basically only bring back data which is in this middle bit here. So let's put a little sticker there. Let's make that a bit smaller. There we go. So this area here represents our inner join. What it means is that if we have a record in table A and a record on table B, it must exist in both tables. So if we had ID1 in table A and ID1 in table B, then that would be satisfactory. We'd bring back the record from table A and table B because it satisfies that it exists in both tables. And that's what an inner join means. It means that it has to exist in both tables when we join those two tables together. The other examples, let's say the record existed in table B but not existed in table A, then that would cover this area here and those wouldn't be brought back. And also if the record existed in table A but not in B, then that would be this area here and those records would also not be brought back. It has to exist in both tables, and that's this inner section here, and therefore it's called an inner join. Okay, so the next type of join is going to be a left outer join. So let's write left outer join. We've got a left hand side and a right hand side here. So let's again label these table A and table B. The left outer join says that it must exist on the left side. So let's put some little sticky notes in here. So we'll have one there, again far too big. And we'll put another little sticky note in here. So this is our left side of the table equation. So this says that if the record exists in table A, then always bring it back. Now there's two circumstances. Firstly, it may exist in table A but not in table B. So that's this area here. So let's say we had a record with ID 1 but there's no record with ID 1 in table B, then it would still come back anyway, because it says bring back everything on the left side regardless of whether it's on the right hand side or not. Then there's a second circumstance in which the table may exist in table A, so that's definitely on the left hand side, and it may also exist in table B, so that's this inner join bit here. But regardless of whether it exists in table B or not, it will always bring back all of the records from table A. If there is no corresponding record in table B, then it would just bring back null records. If there are corresponding tables in record B, then it would bring back the corresponding records. So we get the records that are in table A and the ones that happen to match table B. But what it won't do is bring back records that are in table B but not in A. And then we have the opposite situation. So let's copy all of these. Okay, there we go. I'll put those down there maybe. And let's label that a right outer join. Now this is the opposite direction. So this says that bring back everything that's on the right hand side regardless of whether it exists on the left hand side. So if we have record 1 in table B and there's no record 1 in table A, then it will still bring that record back. If we had record 2 in table B and we also happen to have table 2 or record 2 in table A, then it would also bring that record back. So that would be this inner section here. So it doesn't care whether the record exists in table A or not. It might do, it might not, but it will always bring back the records that are in table B or on the right hand side. Then the final common situation we have is a cross join. So let's create a new category for us, cross join. Now, rather than using a Venn diagram this time, we're going to use various different entities. So let's say we've got a record A and a record B in table A. So let's put that over there. And let's say we've got the same again in table B. So that's table A and that's table B. Now what a cross join will do is it will multiply everything that's in table A with everything that's in table B. So we can connect table A to table B and table B to table A. And let's draw a little line like that. Okay, so this is going to take A and multiply it by B and take A and multiply it by A. Then it'll also take B and multiply it by A and B and multiply by B. So this works as kind of like a multiplication table, so that you would end up with AA, AB, BA and BB. So if you were, for example, to put two tables with each other that had 100 records in one table and 100 records in another table, then you'd basically get 100 times 100 as your result. So you'd get 10,000 records. So when you use cross joins, it very quickly adds up to being a huge number of records. So often you try to avoid cross joins. There are a few circumstances in which you use them, but it's generally in situations where you basically want to multiply one table by another. The most common join that you use is going to be the inner join. So that will be requiring that data exists in both table A and table B. And then you also use quite commonly the left and right outer join, although I tend to mainly use the left outer join because whether it's a right or left outer join really just depends on which side of the equation you write the table. And for consistency, I tend to always write it the same way round, so that means I tend to end up using the left outer join more frequently. So these are the four main types of join that you'll tend to use in SQL: the inner join, left outer join, and right outer join and cross join. In the next video, we're going to look at how we actually start writing some of these joins in SQL. So we're going to start with the inner join. Now I've done a quite quick explanation in this video, but if you do want to go a little bit slower and look at some more detailed examples of exactly how these joins work, then I've got another course which is called a complete course in SQL with SQL Server, and we'll go into a little bit more detail on some of these joins. But let's now go to our next video where we'll look at how to actually write inner joins.